Imagine a world where machines don't just process data but understand it, context, nuance, and all. That's the frontier of modern AI research, where breakthroughs in neural architecture, training methodologies, and computational efficiency are rewriting the rules of what's possible. Today, we're diving deep into the latest advancements, shaping the future of artificial intelligence. Whether you're a researcher, developer, or just curious, this is the inside scoop on how AI is evolving and why it matters. Let's start with transformer models, the backbone of today's state-of-the-art systems. You've heard of GPT, BERT, or T5. These are all variations of the transformer architecture, which replaced older recurrent neural networks, RNNs, by leveraging self-attention mechanisms. But here's the technical kicker. The self-attention layer computes relationships between all tokens in a sequence simultaneously, allowing the model to weigh the importance of each word relative to others. This parallel processing isn't just faster, it's fundamentally more efficient for capturing long-range dependencies, like understanding that it, in a sentence, refers to a subject mentioned earlier, even if it's hundreds of words back. Yet scalability remains a challenge. As models grow larger, parameters balloon and training costs skyrocket. Enter sparse attention and efficient transformers. Researchers are now designing architectures where each token only attends to a subset of others, drastically reducing computation. For example, the Longformer uses sliding windows to limit attention spans, while the BigBird model introduces random and global attention tokens. These innovations don't just cut costs, they enable real-time applications, from chatbots to medical diagnostics, without sacrificing accuracy. Now let's talk about training. Traditional methods rely on massive labeled datasets, but that's not always feasible. Enter self-supervised learning, a game changer. By pre-training models on vast, unlabeled text, they learn linguistic patterns autonomously. Take BERT. It masks random words and trains the model to predict them, effectively teaching itself grammar, syntax, and semantics. The result? A foundation model that requires minimal fine-tuning for specific tasks, like sentiment analysis or question answering. But here's where it gets even more fascinating. Recent work on contrastive learning pairs this with adversarial techniques, forcing models to distinguish between similar contexts. It's like teaching a child to differentiate between cat and caterpillar by highlighting subtle visual cues, except here, the cues are statistical patterns in data. Of course, no discussion of AI is complete without addressing ethics and bias. Models inherit biases from their training data, which can lead to discriminatory outcomes. But researchers are now embedding fairness, constraints directly into the training process. Techniques like adversarial debiasing use auxiliary networks to detect and neutralize biased patterns, while differential privacy ensures individual data points can't be reverse engineered. It's a delicate balance, improving accuracy without compromising accountability. Looking ahead, the next big leap might be in neural architecture search, NAS. Instead of humans designing models, algorithms automatically discover optimal structures. This isn't just about speed, it's about innovation. NAS has already produced architectures that outperform human-designed ones in tasks like image recognition. Imagine a future where AI designs AI, pushing the boundaries of what we've yet to conceive. But here's the bottom line. AI isn't just about bigger models or faster GPUs. It's about understanding, not just data but the world. And as researchers continue to tackle challenges in generalization, interpretability, and ethical alignment, the line between human and machine intelligence will blur in ways we're only beginning to grasp. Thanks for watching. If you want to stay ahead of the curve in AI research, hit subscribe for more deep dives into the science behind the tech. And drop a comment with your thoughts. What breakthroughs are you most excited about? Let's keep the conversation going.